This is part 5 of modeling and simulation of a simple parallel bus system. In this video, we'll connect the blocks of SPBS, assigned all the electrical models already. Then we will check the connectivity between the blocks. So let's get started. In the first step, we'll load the project file. People who don't have the project file from the previous parts, you can download it using the link given in the description. Once you have downloaded the file, you can run the Topology Explorer from Cadence Program menu. Select Advanced SI2 license and click on OK. Once the Topology Explorer is open, you have to click over Open Existing Design. Locate where you have saved the file and click on Open. In the next step, we are going to connect controller and W block. So if I will zoom in, just click over Selected Zoom. So as you can see, the controller has two PCB 40 pins and W block has, or the transmission line block has, two left pins, right? We have to connect these two just by clicking over them. Once we do that, a window will open here. As you can see, as of now, there is only two connections between these two blocks, control block and W block, or two PCB or two left connections. As of now, VSS and VSSQ of controller block is connected to ground of W block. First, we'll click over Auto Connect, then select Net Match Bullet and click on OK. Once we'll do that, it will automatically connect all the same nets from both blocks. So as you can see, the DQ0 to DQ7s are connected and data strobe signals are also connected. Then make sure VSS and VSSQ of control block is connected to ground. Here we have few not connected pins like VDD or VDDQ. So we'll leave them as it is because we are not using any VDD in our transmission line block. Alright, you can now close this window. Similarly, we are going to connect W block or two right side of the W block to two left of tuning block. We'll follow the same process. We have to just select these two pins and just connect here. This window will open. Here you can see the net names are quite different here. We know what to do. We have to click over Auto Connect, Net Match, and here we'll select left net should be DQ asterisk, any DQ pins, and right net should be small DQ asterisk, and click on OK. Once you do that, all the DQ pins will be connected here. And here we have some more pins to connect, DQS and DQS asterisk. So for that, you have to just select them one by one. So first we'll select LDQS from W block, which is a positive signal. So we'll select DQS0P from tuning block, right click and connect. So as you can see, these two are connected now. Then we'll select negative of DQS from both of the blocks, right click and click over connect. Alright, so here we go. We have connected all these signals here. We'll close it. Similarly, we have to connect two right of tuning block to PCB of memory. To do that, you have to just click here, connect those and verify all the connections. So as you can see, all the connections are already connected. All right. So you can verify by their pin names and net names. All right. Then you can close this window. Now in the next step, we are going to check the connectivity between these blocks. Since we have made the connection, but still we don't know the transmitter side or the controller side is connected to the receiver or memory side. All right. Because since we have multiple blocks in between these two. To do that, you have to click over Check Connectivity button from the System SI workflow. Once you'll do that, this sort of window will open. Here we have all the received signal, which is the memory side, which has all the DQ from DQ0 to DQ7 and DQS pairs. Then we'll click over Check button to check the connectivity. Here we go. So here we got the past results of connectivity between receiver side and transmitter side. Transmitter side is controller, which has all the same signals and it is correctly assigned. All right. If you want, you can verify that from the IBIS model of memory and controller, the correct pins are connected to each other. Once you are done with the checking connectivity, you can verify it using the frequency response plot for each connections. To do that, you have to click over here. Once you'll click here, you'll get the frequency response plot between voltage and frequency. Here, as you can see, when we are increasing the frequency, we are getting certain attenuation between 1 volt to 0.86 volt, which is quite fine. Similarly, you can verify for other DQ and DQS signals. You can close the connectivity checker window and save the project. To do that, go to Topology and click on Save. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.